Good morning, students. This is Binesh Salvanesan. I am going to handle the subject called Digital Electronics for you. So this is one of the easiest and important paper in your curriculum. So we can very interesting. It's a very interesting paper. So we can solve this paper as a puzzle, like a puzzle, and we will study this paper in an easy manner. Okay. So let's start to the subject, digital electronics. So first, what is digital electronics? So most of the students may know what is digital and what is electronics. So digital electronics is a branch of electronics concerning digital circuits which apply Boolean logic. So this Boolean logic is a simple logic, okay, the simple algorithm that is developed by George Boole, a mathematician, so who developed an algorithm that is called as Boolean algorithm or Boolean algebra. Okay, so this is only comprises of two numbers, that is 0 and 1. So the digital electronics is mainly with two digits, that is 0 and 1s. Okay, so so this digital circuit is represented by electronic logic gates. Okay, so most of the students know what is logic gates. Okay, so logic gates are AND gate, OR gate, NOT gate, and etc. Many gates are there. So we are going to use that all these logic gates to design a digital logic circuits. Okay, so next one is the value is represented by only two numbers. Okay, 0 and 1s. Either we can use 0. So 0 is most probably 0 is false and 1 is for true. Okay. The next one is digital circuits are less vulnerable to noise because there is no additional noises will be added in this circuit. Okay, so digital circuits are less vulnerable to noises. Okay, the next one is digital circuits were invented in the 20th century and is the foundation for all digital communications and computers. So all digital communications, nowadays we are using digital communications only. So all these digital communications will be handled only because of this digital electronics. Now, so the curriculum or syllabus is split into 5 units. Okay, the digital electronics is split into 5 units. The first unit is digital fundamentals. So in digital fundamentals, we are going to study about number system, then Karnaugh map, Boolean algebra, everything. Okay, then the second unit is combinational circuit. So how to design a simple circuits, that is arithmetic circuits. Okay, so this is the second unit. Then third one is sequential circuit. So sequential circuit is some memory will come in this circuit, so that circuit is called as sequential circuit. So we are going to study about the design of sequential circuits. Okay, then fourth unit is asynchronous sequential circuits. Then fifth unit is memory devices and digital integrated circuits. So these are the things we are going to study in digital electronics. So this is the syllabus for your first unit. First, we are going to study about number system, then number system conversions, that is decimal, binary, octal and hexadecimal conversions, then ones and twos complements arithmetic circuits, then different types of code generators, that is binary codes generator, BCD code generator, then XS3 gray code generator, like that, different types of code generators. Then Boolean theorems, most probably 10 Boolean theorems are there. We are going to study about the Boolean theorems. Then logic gates, AND gate, OR gate, NOT gate, that logic gates. Then universal gates, this is another one important section, universal gates. Then finally we are going to study about sum of products and products of sums. So in this we are going to study about Karnaugh map minimization and Quine-McCluskey method. So these two techniques are very important in this unit. Okay, Karnaugh minimization and Quine-McCluskey method, these are the very important section. So what is number system? So number system is most numbers follow a common pattern for writing down the value of a number. Okay, so for example, the decimal number, for the decimal number we have only 0 from 0 to 9. Okay, the number starts from 0 and ends in 9. So this is called as decimal number system. Then binary number system is only two numbers are there, that is 0 and 1. So likewise, each number system follow a common pattern for writing down the value of a number. Okay, so in every number system we can mention a value of. So classification of number systems. So here, so the number system is classified into four types. First one is decimal number system, then second one is binary number system, third one is octal number system, then fourth one is hexadecimal number system. So these are the different classifications of number system. So here first we are going to discuss about decimal number system. So otherwise we can say it as base 10 number system. Okay, so totally 10 numbers are there. So decimal has 10 values. So the first number is 0 and the last number is 9. Okay, so totally 10 numbers are there, 0 to 9. So the if the number larger values than 9, if we want to write a larger number than 9, we need to add one extra column in the left side. That is, after 9, what is the next number? 10. Okay, so for writing 10, we are adding one extra column in the left side. Okay, left hand side we are adding one more column. So if larger values than 9 are needed, extra columns are added to the left. Okay, now next one is so each column value is 10 times the value of the column in its right. So for example, take this one, 22. Okay, in 22, first the LSB, there is least significant bit is 2 ones. Okay, that is 22 is there. The second 2, take this second 2, this in this 2 ones are there. Okay, then in the next 2, that is in the left hand side 2 tens are there. So 2 tens plus 2 ones, that is 22. This is the expansion of this number. Okay, this is decimal number system. The next one is binary, that is otherwise we can say it as base 2 number system. So it has only two values, 0 and 1. If larger values than 1 are needed. Okay, if larger values than 1 are needed, because only two numbers are there, 0 then 1, then what is the next number? So we need to add one more column in the left side. So if, in decimal number system, after 9 we are writing 10. Okay, similarly here first number is 0, second number is 1, then the third number is 1 0. Okay, third number is 1 0, then fourth number is 1 1. Like that the order will increase. So each column value is now twice the value. So in decimal number system, each column value is 10 times the previous number. Okay, here twice the previous value, like this. So for example, if you are taking 1 1 in binary, okay, 1 1 in binary, then in the right hand side 1, there is 1 1 is there, and left hand side 1 1 2 is there. So here 2, here 1. So the 1 1 value is actually 3. Okay, 3 is 1 1. Then octal. So octal has 8 values from 0 to 7. So if larger values are than 7 are needed, the next number is we need to add one more column like this. Okay, so for writing 33, 3 8s and 3 1s are here. Okay, so this is octal. Then we are going to hexadecimal number system. Okay, hexadecimal, the base value is 16. So totally 16 numbers are there from 0 to 15. Okay, 0 to 15. So after 9, for representing 10, we will write it as A. Okay, 10 is, we will write the value of 10 as A, then 11 as B, 12 is C, 13 is D, 14 is E, then 15 is F, like this. Okay, so 16 values are there. So we can say it as, normally we can say it as 0 to F, totally 16 numbers, 0 to F, that is 0 to 9, then A, B, C, D, E, F. 10 to 15 is written as A, B, C, D, E, F. Okay, so after F, what is the next number? After F, the next number is 10. Okay, 1 0. So after 9, it will become A, B, C, D, E, F, then it will goes to 1 0. Okay, 1 0, that is 10. 11, 12, 13, 14, 15, 16, 17, 18, 19. After 19, the next digit is 1A, 1B, 1C, 1D. Likewise, it will continue. So, for, if you are mentioning a value 44 in hexadecimal, means that is 4 16s plus 4 1s are there. 4 16s and 4 1s are there. Okay. So 4000 means 4 into 1000. Okay, first 4 into 1000, then 300. So 3 into 100, then 2 into 10, and 1 into 6, like that. So this decimal is represented by 1000, 100, 10, 1. Or from the left hand side, from the right hand side, we can say it as 1. 1 time, 10 times, 100 times, then 1000 times, 10 times. So each column is 10 times the previous column. Okay. So in binary number system, here look at this last column. Again, the last column value is 1 times. Okay, 1 times. The next one is twice this one, so 2 times. The next column is, that is second column, so twice this 2. Okay, 4 times. Then again twice this value 8. So like this order will increase from this side. Okay. Then for octal number system, take the last column. Last column is 1 times. Then 8 times of this previous column. Then again 8 times. So 8 into 8, 64. Then 64 into 8, 512. So likewise, it will changes with 8 times of previous column. Okay. Then for hexadecimal, the last digit, last column is 1. Then previous column is 16 times of that value. Then 256 times. Then 4096 times. That is, each column varies with 16 times than the previous column. Okay. So likewise, each number system will follow a hierarchy. Now, so 10 power 10, 10 base 10. 10 base 10 represents the decimal value 10. Okay, 10 base 10. In decimal number, 10 is 10. In decimal number 10, the value of 10 is 10. Okay, 1, 10 and 0 units. Then in binary number system, 10 value, 10 base 2. The value of 10 base 2 is, so look at this, 1 into 2. Okay, 1 into 2 plus 0 into 1. 1 into 2 plus 1 into 2 plus 0 into 1. So 1 into 2 is 2. Okay, plus 0 into 1, 0. So 2 plus 1, the value is 2. So 1 0 value is 2 actually. Okay. Then for in octal number system, 10 base 8. Okay, 10 base 8 represent octal value 8. So 1 into 8 plus 0 into 1. Okay, 1 into 8 plus 0 into 1. Then here 16, here hexadecimal number system, 10 base 16 represents 1 into 16 plus 0 into 1. So the value is 16. So in each representation, the 10 will have some other values. Okay, for decimal number system, the value of 10 base 10 is 10. In binary number system, the value of 10 is 2. In octal number system, the value of 10 is 8. In hexadecimal number system, value of 10 is 16. Okay, so in each number system, the same value will vary. So the system radix, the base of the number system, that is 10 base 8 or 10 base 16, the base 16, base 8, this is called as radix. Okay, so the decimal number system has the radix of 10, the octal number system has the radix of 8, hexadecimal number system is radix with 16, and the binary with so this is the different types of number system representations. So base 10 or radix 10 representation, from the first column, the value will start at 0 and ends on 9. Okay, in binary, the value starts on 0 and ends on 1. Then in octal, the value starts from 0 and ends on 7. Then after 7, the next value is 10. Then 11, 12, 13, 14, 15, 16, 17. After 17, this will goes to 20. Okay, likewise the value will change. In hexadecimal, 0 to 9, then 10 will be represented as A. So 0 to 9, then A, B, C, D, E, F. Then after F, the next digit is 10. 10, 11, like this, it will continue. Okay, so after 20, it will become 2A, 2B, 2C, 2D, 2E, 2F. Then after 2F, it will become again 30, like that. So this will increase. Okay. Then, so we are coming to the main section, that is conversion of one form of number system into another form of number system. Okay, so see this figure. So binary octal, so BIN is binary, then OCT is octal, HEX is hexa, and DEC is decimal. So we convert each and every number system into other number system. For example, look at this binary. So the binary will convert it into decimal number system, the binary will be converted into hexadecimal, again the binary will be converted into octal. So likewise we can convert one form of number system into another form of number system with some easy calculations. Okay, so now we will discuss about octal to decimal number system. Okay, so first write a problem. So take your note and write this problem. Okay, convert 126 base 8 to decimal. Convert the number 126 base 8 to decimal. So all of you took the note and write this number 126 base 8. So how will we convert this 126 base 8 to decimal? Okay, so each digit, that is 126 is the multiplies of 8. Okay, powers of 8, or we can say it as powers of 8. So first we need to multiply, take the last digit. What is last digit? 6. Okay, 6 is the last digit. So 6 into 8 power 0. Okay, so last digit into 8 power 0. Then the next digit into 8 power 1. Then again the next digit into 8 power 2. So 126 is like written like this: 1 into 8 square. Okay, 1 into 8 square plus 2. 2 into 8 power 1 plus 6 into 8 power 0. So multiply this value. So 1 into 8 square is 64. So 8 square is 64, 8 power 1 is 8, and 8 power 0 is 1. Okay, so we will get 1 into 64, then 2 into 8 as 16, then 16 into 1 as 6. So by adding this value we will get the decimal number values 86. Okay, so write down this problem. 126 base 8. So 64 plus 16 plus 6, that is equal to 86. Okay, just copy this problem. So now let's move on to the next one, binary to decimal. Okay, by first we converted octal to decimal. Okay, first we converted octal number to decimal number. Now we are going to convert a binary number to decimal number. The same method is followed here also. So convert 1101 base 2 to decimal. Okay, convert 1101 base 2 to decimal. So now same procedure. Okay, so what we will do, totally 4 digits are there. The last digit is 2 power 0. Okay, the last digit is 2 power 0. Then the next one is 2 power 1, then 2 power 2, 2 power 3, like this. Okay, so how will you write for this one? Take the last digit 1. Okay, 1 into 2 power 0. Then the previous digit is 0. So 0 into 2 power 1. Then 1 into 2 power 2. Then 1 into 2 power 3. So 2 power 3 is 8. Okay, 8. Then 2 power 2 is 4. 2 power 1 is 2. Then 2 power 0 is 1. So 8 plus 4 plus 0 plus 1. Okay, 8 plus 4 plus 0 plus 1. So the value is 13 base 10. So 1101 base 2 is converted into decimal as 13 base 10. Okay, so 1101 base 2 is equal to 13 base 10. So solve this problem. So okay, then on to the next slide. So hexadecimal to decimal. Next one is hexadecimal conversion. Hexadecimal to decimal conversion. Okay. Now convert B2D16. B2D base 16 to decimal. So this hexadecimal number. So the numbers will ranges from 0 to F. Okay. The number will ranges from 0 to F. So first digit is B2D. So what is D? What is the value of D? D is 14. Okay, D is 14 and B is 11. B is 11 and D is 14. Okay, now what will we do? Sorry, D is 13. Okay, D is 13, then B is 11. Now so the last digit is D. Okay, so D into 16 power 0. We need to multiply with the powers of 16. So first one is D into 16 power 0, then 2 into 16 power 1, then B into 16 power 2. So 16 square is, normally we know, 256. Then 16 power 1 is 16, then 16 power 0 is 1. Okay, so 11 into, so B is 11. Okay, so write down this value. B is 11, then D is 13. So 11 into 16 square plus 2 into 16 power 1 plus 13 into 16 power 0. So we will get the values like this. So 2816 plus 32 plus 13, that is equal to 2861 base 10. So the B2D base 16 is converted into digital like this. Sorry, decimal like this. 2861 base 10. All of you please copy these values. So this is the method to convert hexadecimal number to decimal number system. So now we converted octal to decimal, binary to decimal, then hexadecimal to decimal. Okay, so we converted 3 different forms into decimal number system. So similarly, so now we are going to convert a decimal number to octal number. Okay, decimal number to octal number. So this is one of the easiest method. So for example, we are going to convert the decimal number 86 base 10 to octal. Okay, 86 base 10 to octal. So first we need to divide this one with the system radix. What is system radix? So what we are going to convert this 86 into octal. So octal radix is 8. So we are going to divide by 8. Okay, then by dividing 86 by 8, what is the answer? We will get the answer as 10. So answer is 10, the remainder is 6. Okay, 10 into 8 are 80. So the remainder is 6. So similarly, again we are going to divide this 10 by 8. 10 by 8. Okay, so what is the answer? We will get 1. Isn't it? 1. Then remainder is 2. So we will get the answer as 1 and the remainder is 2. Okay, again divide this 1 with 8. Okay, divide this 1 by 8. So by dividing 1 with 8, what is the answer we will get? There is no answer. Okay, so 1 is, we will get as 0, then the remainder is 1. Now the next step is we need to write the answer. Okay, so the answer is written from the bottom, the remainder, bottom to top like this. So first digit is 1, the next digit is 2, the next one is 6, 126. So 86 in decimal value is converted into octal as 126 base 8. So 86 base 10 is converted into octal as 126. Now the next one is to convert a decimal number into binary number. To convert a decimal number into binary number. So here, so we are going to convert the decimal number 13. Okay, we are going to convert the decimal number 13 to binary. We are going to convert the decimal number 13 to binary. So divide 13. Okay, divide 13 by 2. First divide 13 by 2. So by dividing 13 by 2, what is the answer we will get? We will get the answer as 6, isn't it? The answer is 6 and the remainder is 1. Again divide this 6 by 2. So what is the answer we will get? So 6 by 2, what is the answer? 3 and the remainder is 0. 3 and the remainder is 0. Again divide this one. So 1 and the remainder is 1. By dividing 3 by 2, we will get the answer as 1 and the remainder is 1. Again 1 by 2. So the answer is 0 and the remainder is 1. Now write the answer from bottom to top. 1101. Okay, the answer is 1101.